All right, a video, hopefully this is recording, over heat transfer equation. So for energy needed to heat something up or cool it down, basically. Hopefully, video's short, sweet, to the point, and teaches you. Crazy, right? What does this equation do? Well, first of all, what is it, I guess, right? We're going to start with that. The equation is called Q equals M times C times delta T. Okay? Um, it probably helps to understand what this does for us before jumping too far into it. So I want you to picture that if I had, a hot plate. Here's my hot plate. Look, it's even got the coil. Look at that. Look at my art skills getting so good, quote unquote. And it's hot. It's a hot plate. And we put a glass of water. We put a beaker, perhaps, right? Put a beaker of water on there. Look at that. We'll even use blue. Look at that. Even though water's not blue, but that's okay. Um, and we got water in here, and there's heat. We use red for that. Look at that. Artistic. We got heat coming in and doing what to the water? Heating it up. This equation tells me how much heat, how much energy I need to supply to a certain amount of liquid, in this case, liquid water, right? It could be anything. It could be solid gold. It could be gaseous hydrogen. It could be any substance. In this case, it's liquid water. C, we'll get back to in a second. And then this part right here, delta T, is how much hotter, in this case, I want to make the water. So I want to increase the temperature by how many degrees? That's delta T. C is the substance, and it's specific to what's in the beaker in this case, so it's liquid water. Okay, and we'll talk about that more in depth in a second. But this is what we would use this equation for. Okay, you could also do it where maybe I put my ice cube tray. Oh my God, that's terrible. Try that again. Oh boy, I don't like it. Need to erase it. Nuke it from orbit. There we go. All right, my ice cube tray, I guess. Yeah, there we go. Try that again. Oh, that's better. Okay, here's my, oh boy. Oh, whatever. This is me being a chemistry teacher, not an art teacher. Yeah. Chemistry slash physical science slash physics, a lot of things. Anyway, so we put water in here, put it in the freezer. So now it's in the freezer, right? Oh, it's cold. Ooh, it's in the freezer. And energy is leaving the water, right? The refrigerator, in this case the freezer, is pulling energy out of the water, and that causes it to freeze. Okay, this could be used to figure out how much energy is pulled, removed from the water to make it freeze, for example. Okay, and that would require two steps, which I don't want to get too ahead of ourselves, but that could be a little more complicated if it's freezing, okay, or boiling, or undergoing phase change in general. But anyway, so hopefully you said, okay, I kind of get it. This equation is used to figure out how much energy is transferring. Okay, so let's do a sample problem. Let's go back to our heating water. Let's say that we have, make it nice and easy. Let's say we have 100 grams of water, 100 grams of H2O, liquid water. Let's say the temperature starts at, let's just say, 20 degrees Celsius. It's like kind of room temperature, okay? And let's say I want to heat this to, let's say, 95 degrees, nearly boiling. 95 degrees C, which would burn you badly. This is very hot. That would be somewhere around 200 degrees Fahrenheit, like 190 something. Okay, it'd be very hot. And we want to know how much energy is this hot plate going to have to supply to the water? So what I would do if I were you is I'd list out our variables. Okay, so Q equals MC delta T. Do we have Q? We don't. We need to figure that out. That's our variable we're trying to find. Okay. Do we have M? We do. We have 100 grams of water. Do we have C? We do. Now, it doesn't say it in the problem, right? You're going, where does it say it? Okay, this would be given to you, and this is a great time to talk about what it is. So C is the specific heat. Specific heat. It's sometimes referred to as the heat capacity. Okay, heat capacity. Now, heat capacity is basically how much energy can be stored in this substance. Okay, it's one way to think about it. Specific heat is kind of like how much heat does it take to cause it to increase in temperature. So what does this mean? If you look at the unit for this, it looks weird, but it actually makes total sense. The unit for specific heat is joules per grams times degrees Celsius. What does this mean? It means how many joules does it take to heat 1 gram of the substance? It could be water, it could be gold, it could be hydrogen, it could be nitrogen, it could be plastic, it could be anything, right? This is an intrinsic property of any given substance, is that it has a specific heat. Okay, so how many joules does it take to heat 1 gram of the substance? 1 degree Celsius. Okay, for water, this number is very nifty. I shouldn't say nifty. I don't know why I said that. For water, it's very specific, I suppose. 4.184. Okay, that would be for liquid water. So if you use liquid water, it means if you want to heat 1 gram of water, 1 degree Celsius, guess how many joules you need? 4.184. Okay, if I had 2 grams of water, I would double this. If I'm heating 1 gram of water 10 degrees, it would be 10 times this, and so on and so forth. Incidentally, this is the same thing as a calorie. A calorie is that many joules. Okay. Now, before you get excited and say, "Oh, that's like food calories," we use kilocalories in America. We don't call them kilocalories. We should, because they're not calories, they're kilocalories. But kilocalories, 1,000 calories. So in food science, when we say calories, we really mean kilocalories, 1,000 calories. But anyway, you don't need to know for this class, just a fun little piece of trivia. So anyway, yeah, we have this for liquid water. This would be given to you for liquid water, 4.184 joules per grams times degrees Celsius. And then lastly, delta T. Remember, it's delta. Delta means change, so we need the change in temperature. Delta T is always going to be the final temperature minus the initial temperature. Okay, it's always where you end up subtracted from, or subtracting where you started from that. Okay, this is important because if we get a positive delta T, it means it's getting hotter, and if we get a negative delta T, it means it's getting colder. The object, that is. So what does that mean? You better make sure you put the numbers right. So what is our final temperature in this case? We said 95, right? We're going to 95 degrees Celsius. We started at 20. So our delta T is positive 75. Okay, positive matters big time. So now we have these, and we can get this. Plug in our numbers. Let me erase all this, and we'll do that. Okay. So Q equals what? 100 grams times 4.184 joules per grams times degrees Celsius times what? 75 degrees Celsius. And hopefully you're saying, oh, I see, the units cancel. Grams go bye-bye, degrees Celsius goes bye-bye. We're left with joules, which is what Q has to be. That's nice. So let's see what we get for an answer. Bring it up on the screen. Look at that. 100 times 4.184 times 75. Oops, that's 74. And we get 31,380 joules. Oops, 380 joules. This means if I want to heat that much water, 100 grams of water, 75 degrees, I need that much energy. Notice there's no time included in this. That doesn't tell you how long it takes. It just tells you how much energy you would need to do that. Okay, which is useful because if you were trying to figure out, for example, like how long something's on the hot plate, or you're trying to figure out, for example, how much energy from the wall, like the electricity, right? We could figure out how much energy is being supplied, and we could figure out, for example, how long it has to be plugged in for, or all sorts of things. It's also used for chemistry, because I could figure out, for example, like if I react this many grams of aluminum with this many grams of rust, right, how much heat will I produce, right? That's the thermite reaction. That could be very useful. Okay, so you guys have a lot of purposes. All right, but we'll call it quits there. Just one short video or one short example. And yeah, you could have different permutations, right? Algebra, you could solve for M. You could solve for delta T. You could solve for specific heat if you don't know it. Unknown substance, you could figure it out. Okay, so yeah, that's that. And hopefully you have a great rest of your day. Have a nice day.